I'm a lot more dynamic in person, and I've had a full night's sleep. And so, but, anyway, so today I'm gonna be focusing more on energy, and we'll talk a little bit about embodied energy, net zero energy, and I'll get into a little section about energy relative to the design of the building. As an architect, you have a major role in that, and so I kind of want to focus a little bit on that side. My background is primarily from the general contractor side, and our viewpoint is we will do whatever you tell us to build as an architect. We bid it that way, so we'll build it that way. And so you have a lot of responsibility in this area, in that I know some architects that look at, well, energy is primarily a mechanical system that takes care of that, and so they don't really worry about it. It's not the case at all. And hopefully after today's lecture, I'll get you guys motivated, excited, and thinking, yep, there's a lot I can do, and look forward to changing the world. So that's kind of our goal for today. And let me go ahead and go over to the PowerPoint. And, I'm excited. You guys you got a great audience. And as usual, if you have questions as you go along the way, send a chat. Let me know. You know, I believe in very informal situation, and I think it's the best way to help learn. So hopefully some of this is a refresher, and maybe I'll share some things that you haven't thought of before. So we'll see. My full screen, and to back to here. All right, move my screens around. Okay, so I have a button somewhere where I can share screen. All right, excellent. You guys see, I got the right name for today's meeting today. And so, all right. Okay, so we're here on the 19th of October, and so on Wednesday we'll talk about sustainable indoor air quality, and I'll get into a lot more of the thermal properties, lighting properties, things like that. And we're going to realize after, from today's lecture, we're going to talk on it from an energy standpoint, but then we're going to talk more on Wednesday concerning the human aspect and the human input from that. And then the last lecture will be on Friday, green building development. I'll talk about LEED. I'll talk a little bit about green globes, and I'll try to show some examples of projects that I've worked on in those areas. So kind of a short outline, but there's lots behind these areas, and a little bit of energy basics. I just want to familiarize you with what we talk about in the U.S. And imagine some of you would, if you're working with U.S. clients, if you're working in international type environments, it's good to understand a little bit of the terminology. I'll try to cover some of that portion a little faster since it should be a refresher. Design impact on energy, kind of the impact that you can have as an architect relative to that. And then I've got a few case studies to show. So, all right, got some energy basics. I kind of like this picture. Shows a nice variety of energy production all in one spot. And wind turbines, unique one. We'll talk about that here in a minute. And, do you have a lot of wind turbines in Indonesia?
Not really, no.
We don't either, right? And so, when I was in New Mexico, we had a lot, but I'll talk about some of the issues with that. And so, all right. So, kind of one of the big driving forces. So this I just got from U.S. the NASA site, National Aeronautics and Space Administration. They track the world climate change, and this is in degrees Celsius. So we've gone up quite a bit. So this is a relatively recent one, and so we recognize that we got a major issue, and so how to address that? Probably, the scientists have come up with a pretty clear relation between our carbon levels and the climate change elements. And so that's why carbon becomes a key element that we want to track in, what our carbon emissions are. So things that we can do to reduce that carbon is critical. And energy, when you look at so many of our fossil fuels, it's a direct release of carbon into the environment. So anything we can do to reduce those fossil fuel emissions can make a huge impact. And a lot of people say that we need to make we should have started making changes back here, right, in the 1990s. And so hopefully we haven't gone too far, and I'll talk some of those ideas briefly in a minute. But anything we can do to help, it's got to be done. So some general terminology, energy and power. We typically refer to energy in the US, everything is in kilowatts, kilowatt hours.
Professor, are you there? Or is it me?
We can't see him either.
Okay. I will text him. Wait a minute.
I think Professor is disconnected from the room.
Okay. Okay, he's out. No. Hello, Professor?
Sorry about that. My system died out on me. Can you hear me
Okay.
now?
Yeah.
Sorry.
It's okay. Thank you.
Sorry about that. So, okay.
No
So what
problem.
we're looking at is the whole flow of energy through a system. And so energy is used in every process, from the extraction to the manufacturing and the building itself, for operation of the building, and then finally to get rid of it. And so it's a very convenient way to recognize how much carbon gets emitted throughout the entire process. And anything we can do to reduce that is going to make a major advantage for the environment. And so it's kind of a we can track this in a variety of different ways. And so we typically call that that tracking the process is referred to your embodied energy. And so everything that we deal with, right, anything as simple as a little pen, to as complex as buildings, to entire cities, everything has a certain amount of embodied energy to it. And so the key in doing our product selections needs to be to evaluate how much embodied energy does each of the particular products emit. And so when comparing, right, do I want to use my glass or my coffee mug? Which one is better? The ideal way to do that is do an embodied energy analysis. And the most effective way, the tool for that is, as we mentioned in our last lecture, using your life cycle assessments. And so life cycle assessments look at every phase of the process and the energy used in that. One of the key aspects of this is what was the source of the energy in the production process. Did they use coal? Did they use fuel? Ideally photovoltaics. And so when they do your environmental product declarations, when a third-party company comes in and evaluates the product to give it certification, that's what they look at. They sit there and say, all right, so you got your power from the local utility grid, and all the I know in the United States, all of your local utility grids have to be evaluated based upon how much renewable energy goes into it and where the sources are, and so they can immediately know what the carbon emissions are relative to that. And so, do they do something? Do you have the same process in Indonesia? Do they require that all your local utilities report what percentage comes from what sources? Do you do that in Indonesia?
I don't think it's in that detail, Prof.
They don't do the same detail. And so, Yeah, it makes it easier when they have to report it automatically. If they don't, then when doing the EPD, you've got to go to the companies and find that out. And so when selecting products using the EPDs, is a very useful way to help reduce the overall embodied energy. One of the things that we often fail to capture is, for buildings in particular, the majority of your embodied energy actually comes during the operating phase, during the time in which you're actually maintaining the building, the 40-some years that you're running the building, in which you're continuing to use energy, you continue to do replacements of the equipment. And so things that you can do up front to reduce your operating energy make a tremendous difference in the overall savings for the building. And so always keep that in mind. It's not just the very beginning, just the production side. Okay, it's this whole operating phase that you also need to keep in mind when selecting materials. What's going to what lasts longer, what has the highest durability. So I think we talked on some of that a little bit earlier. So some basic definitions to go with this. So our intent is, what we want to do is get to what we consider a net zero state. A net zero state would be the energy you consume, right, is offset by the energy you produce on the site. So, ideally, in this particular situation, here's your consumption, so much energy, and here's your particular amount of generation of energy. And so when doing this calculation, so if just putting a photovoltaic panel on your roof in itself, it's helpful, but it's not really, unless you design it to the proper size, it's not really getting into the full net zero state. And so so there's a number of ways that they look at net zero. Okay, there's net zero for the site energy, and so much energy is used on the actual site. One of the things to recognize, though, is that your energy that you use in your buildings is usually generated at a power plant, which can be a distance, can be numerous miles away from that particular building. And the process of transferring that energy, let's say if it's 10 miles away to your building, could you lose through the line transmission through the entire process almost half that energy. And so if I'm using 10 kilowatts of power in my building, it takes 20 kilowatts of power to generate that because of your line losses. And so one of the big factors that when net zero specialists look at is source energy, right? So if I want to generate enough power to offset what I'm using, then I really need to look at net zero source energy, not just the site energy. I need to generate twice as much to offset what my power company has to provide to generate through the power line. And so so kind of keep that in mind, that just what you see at your end is not the end of the story, right? You need to look at the other side of that. There's been a lot of research. When I was at University of New Mexico, we had a whole division there that was looking at what's called microgrids. The idea that instead of having great big power plants that generate lots of waste and problems that generate, that cover an entire city, having small little miniature power plants that cover a neighborhood. That way your line transmissions are dropped. You can reduce the amount of distribution energy. And so there's plus and minus of that. And so there's been some research looking at perhaps a microgrid is a better environment. So all right, just some kind of examples of depending upon your particular fuel that you use, right? The source to site ratio. And so relative to the proportion of how much do you lose along the transmission line. So electricity is pretty high, coal, wood, really low. So selecting more efficient electric transmission modes is a lot more effective. The intent with that. So, all right. All right. So the intent, net zero energy emission produces much emission-free renewable energy as it uses from emissions-producing sources. So the whole idea of becoming carbon neutral then is by is you produce green energy that offsets any of the emission sources that were generated otherwise. So, all right. So we discussed already that so much of our energy comes from fossil fuels, and so there's been lots of research into how much fossil fuel. It's a limited quantity, and so we want to figure out how much, at what point, we pretty much maximize our use of it. So there's been a lot of studies that show this just sounds so appropriate for this year, doesn't it? that we would reach peak oil in 2020. So peak oil refers to, relative to the quantities, the resources of energy, right, of fossil fuels. Eventually, it kind of creates this big bell curve, and eventually reach the top of that bell curve. And once you've reached the top of the bell curve, anytime after that, right, then we're just depleting our remaining resources. And so there's been a lot of study on when have we reached that peak performance side. So I just thought it was interesting that back in 2009 they thought this was the year it was going to happen. So anyway, as a result of that, as a result of people recognizing that we need, trying to slow down how quick we're going to reach peak oil, how long before we reach that peak point, there's been a lot of legislation that's gone into effect. A lot of this is European legislation, some US legislation, to try to reduce the amount of energy that we consume. In addition, it creates a lot of regulations for your energy utility companies as far as what they can do, and to try to regulate the pollutants they release, the amount of carbon that they release in the process, carbon emissions. And so over time, there's been a tremendous amount of legislation to try to improve that process. So in the US, the energy plants that we have today are a whole lot cleaner than they were 20, 30 years ago. And so I would hope you'd have a similar situation in Indonesia. Is that, do you follow similar legislation as far as regulating the amount of emissions they have to help, so hopefully that's the intent. I mean, it's still not perfect. We still have a long way to go with that, but we're certainly seeing a lot more of that. And one of the things that we've seen in the United States is most of your big utility companies have gone to providing a certain percentage of power through renewables as a way to regulate that, help with the process. So energy resources, and this is worldwide energy resources. And so the brown is the coal. This is your oil resources, natural gas, nuclear. There's a little small portion here. Hydro, little bump there. Biofuels. This is like corn. What we use a lot in the States for biofuels. Geothermal, a little bit of that. And so this is kind of the overall distribution. You can see over time, kind of kept relatively proportional, but we certainly have been huge growth in that. This is how Indonesia looks. And so, so in Indonesia, oil makes about 12%, natural gas about 29%, hydroelectric, geothermal really small, other renewables pretty small percentage, lots of coal. All right, I was surprised to see this, and when doing my research for this paper, I found Indonesia's huge coal mines, don't you? I did not realize. I mean, it's where are those located?
Borneo, Kalimantan.
I mean, that's. I guess there was part of the when the Dutch ran, were running you. That was their, for the whole the ships, maintaining the coal for that was a big factor. I just did not realize that. Uh, so in Indonesia, most of the energy goes to industry. Transportation, a small portion of it. Commercial, just a smaller portion of that. Housing, these are any kind of energy distributions you typically have for that. And so emissions by fuel, and this is, you can see coal is probably one of the as far as the CO2 emissions you get off of it, coal is one of the worst ones you can get. Oil, natural gas are other big emissions. So anything we can do to reduce those will certainly make it a whole lot better. I saw an advertisement when I was in New Mexico from one of the local Native American tribes about how they produced clean coal. Their clean coal doesn't reduce, doesn't emit CO2 when burning. And I'm like, really? That's kind of impossible, right? And so be careful of people that talk about clean coal. And it certainly it emits less than steam coal, but coal is still it's a fossil fuel, and so it's going to you're going to have issues with that. So from worldwide, for the world traders of energy sources, I thought this was really interesting that U.S. is kind of right here. We export as much as we use it within ourselves, and Indonesia is, you're really big. You export a lot more than you use for coal, and I was really amazed at that. And so I imagine you get a lot of political pressure to keep things the way they are, right? I mean, coal it seems like such a huge industry for you, and so this is kind of an interesting one as far as the coal importers, coal exporters. You're actually on the better side of that, right? Because you don't want to have to rely upon coal, right? You'd rather be selling it to somebody else, and so it's financially it's better for you in that sense. But I thought this was the interesting one also. So the biggest exporters, I believe you are the largest coal exporter in the world, and so from looking at the 200.2 million tons per year, and so very, very, very impressive. And sure that affects a lot of the mentality. Or most, I think we covered that, right? The power plants, and so I'm surprised you don't have more power plants that are coal relative to that. Is energy in the U.S. Again, a lot of us is petroleum, natural gas, and you can tell how it kind of distributes out to the various industries. And so we get residential, commercial. It's a bit of most of that. We don't. The nuclear doesn't go as much to us. So one of the things that often gets addressed as the ideal energy source is solar PV, and the idea that it's comes from the sun. It's free essentially, and in the production phase, it's there's no emission of anything. The problem that we run into, when we talked about this before, with if you look at the embodied energy for solar, it's a little bit more a little bit more energy intensive. I've heard of solar photovoltaic plants that are using solar power to produce the solar power, so that's certainly helping. But you still have a lot of chemicals involved in the extraction process, and so depending upon where you get your solar panels can make a big difference. And so in Indonesia, the distribution makes different provinces. It looks like Kalimantan is probably the biggest user of that. Is that what area is Jakarta in?
It's in Java Island.
In Java
In
Island, Java and Bali.
That's green one.
Java and Bali, and it's the 5% one. Oh, okay. And so, and I need to travel more in Indonesia. so I thought this is an interesting distribution of what type of renewable sources. The hydro must be big water dam systems, and so small hydro, bioenergy is nice. Geothermal, tidal energy. Where do you use tidal energy?
Pardon?
Where is tidal energy used?
I have heard that used in Batam, but in 2025, starting for KEK Batam.
Hmm. I've done some research on tidal energy in Europe, and it's an incredible resource. I mean, it's just, it's the operating side of it's difficult because of the the wear and tear of the ocean, but I mean, just a really good resource for energy. All right. So staying with the photovoltaic side, one of the nice things with photovoltaics is the price has really been coming down over time. And so in the US, my next door neighbor actually owns a photovoltaic distribution company, and he keeps being posted on the current price. And in the US, we're currently at about $2 per watt for photovoltaics. And so it's getting a lot more reasonable for that. This is the photovoltaic. This looks at US, Alaska, Germany, Spain, and I had you guys look at Indonesia as your homework. And so the idea is you want to try to find what your kilowatt hours per meter squared per year is. And I taught a class a couple years ago in Germany on sustainability, and my students were all really impressed that you see photovoltaics all over the place in Germany. But you look at the amount of kilowatt hours per meter squared, it's extremely low. I mean, you're in a very northern climate. They don't get a whole lot, and yet they still can make it work for them. When I was in New Mexico, which is a very solar intense area, there's disappointingly very low amounts of that. So hopefully all of you are able to look up what your location, what your photovoltaic levels were. So based upon that, we can kind of go over the quick calculations for your homework. So where I am in Florida, assume I get about 3 kilowatt hours per meter square per day on an average, okay? And so I think in Indonesia, most of your ranges are between 3 and 5 kilowatt hours, was what her chart showed. So if I was to assume a 1 kilowatt array, very basic size, so basically takes up 1 meter to balance out my 1 meter, and I look over 365 days a year, that means I'd be generating a little over 1,000 kilowatt hours from my 1 kilowatt meter array. Unfortunately, one of the big problems you have with the photovoltaics is the conversion. So the photovoltaics is going to generate power in DC. Most of our homes use AC, so you need to run through some type of inverter system to convert that. Plus, you're going to have line losses. So right now, it's pretty good. It used to be a lot worse. It used to be you'd lose 50% of your power due to conversions. Now we only use about 25%. So if I take that 1,000 kilowatts, take away 25% of it, about 800 kilowatts of actual usable power. And so I did this based upon what you would have in Indonesia. And the estimate I had is that you pay about 1385 rupiahs per kilowatt hour. Does that sound reasonable for you? Roughly?
I think
Right,
it's
so-
got 1,600 something.
1,600? Okay. So when you're doing your all of you should be doing your calculations now on your own, right? Relative to what you did for your size of your array. So you're saying 1,600 is the rupiahs. So based on my example, if I was doing this amount, I'd be saving about 1,137,000 rupiahs per year. I was estimating, I saw that I did a quick look for cost of photovoltaics. In Indonesia, you've actually got a very reasonable rate for them. Does that seem reasonable for a 1 kilowatt array to be about 10 million rupiahs?
Sorry,
Or
Prof.
is it-
Mark, I just opened the website here. So according to our Ministry of Energy,
Mhm.
yeah, they have grouped some kind of capacity in their home, right?
Mhm.
So we have, sorry, my first information was wrong. We
Mhm.
have like 1,100.
Okay,
Mhm.
so
And
that's
some
close.
also 960. I'm not really sure. I will check again
Yep.
then. Yeah.
Okay. And so if we estimated that it costs 10 million rupiahs for your per kilowatt array, right? And you're saving more than a million per year, you have a payback period of less than 9 years, which is actually very reasonable. Most photovoltaics last up to 20 years. And so as long as you're getting a payback in less than 10 years, it's become a much more financially feasible option. And so what did you guys find for your calculations? Was anybody, what type of levels were you of solar radiation were you seeing?
Hello, sir.
Yep.
For this homework, I calculate the potential PV for my house, but not the energy time cost for electric. Actually,
Yep.
I did two calculation. First, the first one, I calculate the size of my roof. I got 160 meters square, and
Nice.
The solar panel itself, it's the dimension of the solar panel is 2 meter square. So for the potential solar panel that I can use is about 80 panel. Yeah.
Really?
Yeah.
Wow. Nice.
If I use all of my roof.
Right. Sure.
All of my roof, yes. And then for the solar panel that is available in Indonesia, I found it is one panel is 350 kilowatt hour.
Okay.
Yes. So for 80 panel, I got 28 kilowatt hour.
Nice. Yeah.
Kilowatt hour. So for the potential PV per day, I got 95.2 kilowatt power.
Wow.
Yes, that's the first calculation I got. The second one, I use a website called Calculation Solar. Here they calculate that I can use the total consumption of my house is about 34,000 watt hour per day.
Right.
And then they calculate my my real energy daily is about 41,033.17 watt hour per day. So the PV model characteristics, I'm sorry, I'm kind of confused. So the power system performance ratio-nya is about 82.88%.
Right. Yep.
And then they calculate the serial and the parallel photovoltaic system. Yeah, like that. I don't really understand reading this calculation actually.
Sure.
I get that.
Can you share it? If I stop share, can you share the screen?
Sure. This one?
Yeah.
So this is my location and the information and the voltage. I calculate. Sorry.
So real quick, the inclination and the is they did that based directly upon your location, correct? They filled that in.
Yep.
Right. Yeah. And so it's kind of neat. It's pretty kind of, it goes directly off of almost what your latitude is. And so okay, good.
And then for the energy consumption, I made some assumption.
Sure.
From the using, and then this is the total consumption.
Yep.
This is the result. I don't really.
Well, go back. How did that relate, your total consumption? How does that relate to what you actually? I mean, that's 34 kilowatts a day, right? Is that what you actually get for your energy bill? Is that close?
Yeah, I think so. Yeah.
Okay.
This is from my calculation from what I pay for the electricity, So
Okay.
I pay 1,500 per month,
Okay, right?
and then I divide it by the cost,
Okay.
by the cost that electricity in Indonesia costs. But I divide it by 1,044.
Yep.
So it's about so it's about 34,000.
Okay. Excellent. Excellent. Good. Okay.
Then
Nice.
it's the result.
Yep.
I don't really understand how to read this. Actually.
Okay. So this is the top portion is the actual panel itself,
Mhm.
right? And so the 48 volts, it's because it's the DC power, right? It's got to run through an inverter. And so the efficiency, the performance ratio is actually really good. And so it's showing, I was estimating usually about 75%. So that's showing it's a good amount. And so you're actually getting about 41 kilowatt hours per day. Okay, nice. PV module characteristics, your Luxor, polar crystal. Wow. Okay, nice. We'll use. And then it's because it goes from your photovoltaic. This is your inverter system. Okay, so they're talking about that. 104% performance. That's really good.
Which one is
So,
that? Oh, this one.
So then, they're thinking if it goes into a battery system,
Yeah.
right,
They
as
think
opposed to the charger inverter.
Yep.
Okay. Yeah. See, in the United States, we rarely want to run it into a battery system. We actually prefer to run it into the grid. And so
the question for the off grid, yeah.
Mhm. Yeah. So if you're running off grid, if you don't have a grid available, then or if your grid is not reliable, battery is fantastic. The drawback to that is, so in the U.S., if I run into a battery system, if I run into the grid, then my power company sends me a check. Because I'm providing power to them, and so I make money off of it, right? And so because in the middle of the day when I'm typically not home, right, then it's generating lots of stuff, and so the batteries have gotten a whole lot better. This is fantastic. So nice. What's the next page on it, Show?
That's it. I got this. That's only this.
Okay. So what you want to do from this is you're generating 41 kilowatts per day, right? Times 365 days. So you've got 14,965 kilowatts, right?
Yeah.
And we're estimating it's costing 1385 rupees per kilowatt hour, right? Times 4 by 5. So I lost myself in the math when going to rupees. That's right. And so based upon the watt hours per day that you're generating, right? You take that times the number of days.
Sure.
And once you know the total number of watt hours, you divide that by the cost, 1385. What do you get for that?
Wait.
Yep.
Let me calculate it first.
It's 34 kilowatts.
I got 10.3. Is that correct?
110.3
Yeah. Is that correct?
is the amount of energy per day. I mean, energy per year.
Sorry. 14,000.
Okay. Yep. Okay. I agree. And so if you divide that by the 1385, No, times the 1385. Sorry, times the 1385.
165. Oh,
It can be a huge number. I mean, the millions, right?
yep. So 14,000 times 365 and then divided by the price per watt hour, yes?
Wait. Okay, the 14,000 is your total kilowatt hours you provide per year.
Yep.
Right. Okay. And so you take that times, and I think who came up with was it 1,600 rupees per kilowatt hour?
No.
1,400 something. Oh,
Yeah,
Okay.
1,000.
Okay. So take the let's see. Sorry. Yeah, the 14,000 kilowatt hours per year, right? Times 1,400 rupees, right? That's how much money you're saving per year,
Okay.
right?
but Prof. Mark, I
Yep.
think what we have for the price for electricity which come from renewable energy, that's still lower from the coal source.
Oh yes. But what we want to determine is how much money you're saving by using photovoltaics.
To
right?
substitute the sources.
Exactly. Yes. Yep. And that because that will determine your payback period. And so if it's cost effective to do it or not. So and so it used to be when a photovoltaic array was, $4 per watt, or when if you're in a location where you don't get a lot of solar power, it's just not cost effective. You'll run into cases where it's 30-year payback period on an array that's only good for 20 years, right? And so you should find it in your case. So if you're thinking that if an array costs 10 million rupees, and you probably come with a number close to about 1,200, 1 million so many rupees per year as the cost savings, then it's less than 10 years. And so is that kind of what you got, Inka?
Yeah. Roughly, yeah.
Roughly a little around a million, right? Is your savings?
Yep.
Excellent. Good.
Thank you, Prof.
Yep.
Sure.
So yeah, it's a little bit more challenging to do it on Zoom. So
Thank
all right. Okay. So I'm running long. Sorry. I'll try to expedite.
It's okay, Prof.
Okay. Big problems we got is the startup cost, right? Why we don't see a lot more photovoltaics. There's been, at least in the United States, there's been big investments for a big sort of a photovoltaic farms to help offset that. What we do in the United States is we do a lot of subsidies. The same with Europe, as the government will help subsidize individuals to help promote that. And so if the families move, they tend to don't see the payback period. So in the U.S., people move every like 5 to 7 years, depending on your location. So if you're not going to be in the location long enough to get the payback, you're not going to invest in it. And so, one of the problems is the cells can be damaged easily, and efficiency isn't as great as as other systems. And so, certainly getting better with that. And, if you talk to a power company, they often complain about photovoltaics in that they're great during the day. They don't work very well at night. And so the power company has to be able to provide energy for you at night. All right. And, fantastic. You have a source that helps during the day, but, once all those photovoltaics stop working, they still have to be able to generate that power. And what gets difficult for them is their power equipment has this ideal range in which it's optimal. And so it's kind of your car. If you drove your car around at 5 miles an hour all the time, it's horrible. It's horrible for the engine. It's not running efficiently. It's not burning gas efficiently. It's all around. It's kind of the worst environment. If you ran your car around at 200 miles per hour all the time, you'd be having a lot of fun. But again, it's not really efficient either. Most cars are designed for this optimal range of about 55 to 65, miles per hour. And so the engine is designed that it's its peak performance. And so the same with your power companies. They have this, they want their energy generation to be loaded to about 75 to 80% is optimal performance. So during the day, when all these photovoltaics are running, their performance level drops off dramatically, and so they're being inefficient. At night, you've got to have the power systems available, right? And so they become a little more efficient. And so we end up in the States getting a lot of pushback using photovoltaics, because that is your argument. I'd imagine in Indonesia, you probably get a lot of pushback from using renewable sources because you've got a huge coal industry. And so, it's doing a lot to generate, I think, revenue for your country. So there's definitely some issues with that. All right, in addition to solar voltaic, I think this is one of the more kind of interesting ones, solar thermal. The idea is instead of generating energy, what we're gonna do is just generate hot water. And so we actually have a requirement for all government buildings that we have to analyze for new construction to use solar thermal. And so you just you run the water through little collectors, and it creates your hot water for you. It's a very efficient system. Talk about fantastic way to cut carbon. The difficult thing on this one for us is let's say for an example, an office building. If you think of how much hot water do you use in an office building, in the bathroom maybe a little bit, right? And so it's a bit of a challenge in the payback period based upon that calculation for it. But it's a fantastic technology. I've seen that used in barracks facilities where it's much more efficient. So there's been some really neat technology to expand beyond this in using solar thermal to basically create a focused solar beam on a particular source and heat that up and then use that. And so you can also use solar for low temperature heating, solar air conditioning systems, right? Based upon what the refrigerants are for those, process heating, district heating, and desalinization. So there's a number of things in which you can use solar heating. Very efficient. Strongly recommend capabilities. Again, in New Mexico, we had a solar array type of scenario in which what it's doing is using all these mirrors, reflecting that to heat a particular source, and then you're using that heated source to create your fluid flow to run your turbine. And so it's kind of a neat system that they were trying to specialize on. So, all right. So, all right. Next thing is kind of things you can do from the design standpoint. And I think I'm running short on time, so I'll kind of speed this one up. We'll talk more about some of these elements on Wednesday. So this is from one of my favorite groups called the Passive House Institute. And so as architects, how you design the building is critical. This is where you really get into making big differences, because you're the ones that are going to specify the materials you use. You're going to specify the parameters that it's going to be designed by to make this happen. And so just real quick, this is from a group called the Passive House Institute. The insulation that you use makes a world of difference, right? The types of windows is your major loss and gain of your resources. Adequate ventilation strategy. So they use a lot of highly efficient heat exchange systems, and we'll talk about passive a little bit later. Air tightness of the building and reducing those thermal bridges, reducing the amount of temperatures that go through the wall systems. Right? So this is from the Energy Star group, and they're talking about most of our buildings by 2035 75% of the buildings will be either new or renewed. And so we've got a lot that we can do to help improve the overall performance of our buildings. And so if you go to the Energy Star website, they have a lot of resources available to help you in selecting the most optimum materials for that, right? So they really recommend, and you've probably heard this all your careers now, that using the integrated process, starting from that design charrette, getting everybody involved early on is where you really start to make a difference. And so as architects, you're usually the ones that head up that process, doing the coordination. So, establish goals, let everybody work to those goals, and communicate routinely. So for efficiency. So this is from Architect Magazine, How to Construct for Energy Efficiency. And one of the key things is try to get that airspace. Your attic airspace quite often just creates this huge heat source. And whatever you can do to help remove that heat source will help improve your facility. So getting proper air barriers, getting the proper airflow. It's called a deep truss heel. So what it does is it raises the roof up a little bit above the regular ceiling height, so you get a better airflow through that. Helps improve the efficiency from that. One of my favorite things that I ran into when I used to live in Germany and worked for a big AE firm when I was there, and I became familiar with what is a style of design called Passive House. Have any of you heard of Passive House? Anybody? And so I recommend check out their website. Down here at passivehouse.com. And from having visited a lot of passive houses while I was there, I was really impressed. They use less than 75, you get about 75% or more energy savings relative to a standard home. And it kind of takes the idea of, in the facility that we're in right now, you're probably at a comfortable temperature. If you can take that temperature and precondition your incoming air so that you're within 95%, of the same air level, just used on a straight physical air exchange process, all right, then you can get huge energy savings. So the Passive House is they have an institute that provides recommendations on how to do it much more efficient. So encourage you to look at that. Passipedia has some basic rules of thumbs of things you can do. So initially, when I first started, when I left Germany and came back to Florida to work on my doctorate, my original dissertation idea is I was planning to bring Passive House to Florida. And my dissertation advisor, Charles Kibbert, who the second group on last week had referenced him, he was very nice to me. And he was like, until you can solve the humidity issue, I'd recommend picking something else. You'll be doing your research otherwise for a really long time. So if you want to graduate, go on another topic, right? And but I still kept my interest in Passive House. And so it works great in northern climates, but there have been plenty of examples in southern climates also. It's not as ultra efficient, but it still uses some really good techniques on how to help make your buildings a lot more efficient. So design in tropical areas, the big key in like Florida yourselves is keep good air movement. Keeps people comfortable and keeps the heat moving out of the locations. Use of lightweight materials for the walls and roof is recommended. Do not store much heat. Heavy metal products such as brick and block will re-radiate the heat throughout the day. We don't want that. Make sure you use lots of good shading, good techniques. So the orientation is taken care of so that you minimize that solar heat gain from the sun hitting it. We talked about the roof being vented. Consider developing thin, long floor plans. That way you get lots of airflow in the buildings. Use lightweight materials, fully shading eastern western walls, insulating as much as possible, using vented ridges. The whole idea is you want your roof to vent on you. Choosing windows that catch the breeze and can be left open in wet conditions, right? Make a big difference. Usually some louver windows. insect screens. Naturally, if you're gonna have your windows open, you got to make sure you don't have the bugs coming in. Using awnings, putting high-level windows or vents in all rooms. They really encourage planting, right? As much as you can get shading for your facility, as much as possible. But you don't want your planting too close together so you don't block off the wind also, right? Get rid of all the heat island effect. Try to get green spaces around your building, makes a big difference. Keep the living room towards the northeast, capture wind and sun. Locating septic downwind trees. Okay, all right. I'm going over on my time, so I'll real quickly. The recent couple years ago, the AIA came out with what they consider the 2030 challenge, and the idea is to as architects, what you can do as a community to help become more carbon neutral. And so, actually, I know Blue Ova, you're member of the 2030 challenge group. Pataga, do you participate in 2030 challenge?
Prof. Pak Mark, I'm not really a member, but I'm working with the government in that kind of direction.
Could maybe you can talk a little of what you have more direct experience with it than I do, then, so you could maybe share some of what you found with that. So.
Okay, Prof.
So anyway, their objective is to try to become carbon neutral, and ways to do that using energy resources, energy efficient technologies, and design strategies is a major portion to try to reduce the overall energy efficiency. So the whole idea is using a whole building energy simulation method to help improve the performance of the building. And again, these are a number of the techniques, and we'll talk more about these on our next lecture. And so, all right, again, this is some of their information on how to improve it. This is all in the lecture. Just some real quick case studies. This is actually my building that I work at University of Florida. This is Rinker Hall. And when you first walk in the building, I like how it's got this central staircase. The elevator is kind of off to the side. And the idea behind that is encourage people to use that iconic staircase as opposed to going up and down the elevator all day long. And it's amazing what a difference that makes. And so often you come into buildings and the first thing you see is the elevator. So shift it, right? Let's go to that architectural, that beautiful, staircase type thing and encourage that. So this is a project in Arizona where they're talking about the very finishes and materials and what a difference it made in maintenance of the building and also improving the energy performance of it. This is all the analysis they did on the design side and how they got a 41% reduction in the energy usage just based on picking appropriate facades for it. Stabilization wedges talks about all the benefits and efficient methods for that. This is a passive house in, this was in China, similar climate that was able to recognize benefits of that. I won't go into a lot on that. And the last one I was going to talk about is the Great Glen House. This is actually in Scotland, not similar climates to any of us, but I thought it was an interesting, incredible sustainable building. It was evaluated by the BREEAM system. This pond here is a living machine. It treats their sewage water. And when you walk up to the building, it's just a beautiful pond, right? You would never imagine that's their sewage that gets processed for that. And so the biggest problem and why I bring up this building, it did incredible designs to it, but they actually over designed it. All these windows, all these windows, actually, they designed them such that it reduces the amount of heating that it requires, but it's over designed. And when I visited the building, all these people have umbrellas all on their desk, all right, because they get far too much glare, right, and it gets too hot in there. And so I think as my final point, when you run your models, try to simulate as much as possible. And you got to be flexible because the situation they found is that it did great for energy savings, but the building comfort level was kind of dropped off. And so I think that's a good segue into our lecture for Wednesday. We're going to talk sustainable indoor air quality, building comfort. And so your homework for then is think of what's the big impact design-wise that affects your personal comfort in a building. So be thinking of that. And with that, I'll open up for questions.
Okay, thank you so much, Prof. Mark. So
Yep.
that will be the homework for our lecture for Wednesday, yeah?
Yep.
That's triggering questions. Thank you so much.
Mm-hmm.
Okay, then maybe I would like to invite discussion. A moment, we will start. Please, if anyone wants to have questions, please go ahead.
Good afternoon, ma'am and Prof. Mark. May I ask
good
a question?
Of course.
Yeah.
Wait. Prof. Mark, can you turn off the slideshow, that we can see each other again?
Oh, definitely.
Thank you. Yeah. Please
Thank you.
go ahead.
Yeah. I want to ask about the energy consideration about material process.
Mhm.
You encouraged. We have discussed a lot about how the process of making that material itself is consuming energy, and somehow we should consider the less energy that is taken for producing a material.
Mhm.
But I want to ask about the realization, like in practice, maybe for example, like we want to build a building, and we have to take the material. We have to select what material we want to use and where we get the material. How could we know that we choose the less energy consuming material? For example, like we have we should use a concrete, for example. Why? How do we know that this brand is consuming less energy in the process of making the materials than the other brand? Like, are they mention it in their website, or we should take more information personally to the institution, or like I just don't get.
Yep. Well, the quickest and easiest way is require them to provide what are called EPDs, environmental product declarations, and I see that in a lot of specifications now. And so, in fact, in government projects, often the architect is requesting that it's like more than 50% of the products must have EPDs that must be third-party certified as being energy efficient. And so, in part of the certification as an EPD, they'll sit there and look at that product and compare it to other similar products and determine that it is providing an energy savings and is using less number of materials. And so, getting that certification is an ideal way to do that. And so now. So let's say I'm comparing my glasses again, right? My glasses. If both of them have EPDs, ideally you should pick the one that is the most energy efficient of those two. Unfortunately, quite often what happens from the architectural standpoint is because you don't want to. It's difficult when an architect says, "I only want this brand name, this particular product," right? Because once you start specifying the product, I mean, you all recognize the difficulty in doing that. Then you take on all the liability for any issues dealing with that. And so, so what we do end up, I see a lot of is that the architects just specify we want products that have been third-party certified. We want them to have that certification and have somebody evaluate them. So that I hate to say it, it puts it off on the general contractor, right? And so as an architect, you're saying we want it, and it makes the general contractor abide by it. And so now we also, through the submittal process, as a general contractor, I'll submit and say, I'm planning to install this material. Here's my EPD for it. And then the architect, you have the right to sit there and say, no, it's not good enough, right? And so, you know, it doesn't meet what specs I'm requiring for that. So, but we have pretty standard language in our specifications that call out and say, we want products that have bio-based products. We want products with, you know, major recycling content. We want products with EPDs. So it's becoming a little more common for that. In Indonesia, do you have standard specs that do similar?
They are not really similar, but we have just get what they call the certification for the green product label. Okay, and I think that until now the government has not asked the company that they should have such a regulation at this time. I think it's because most of the productions, local productions, are not yet meet that criteria, and that has something to do with the economy actually. But it's growing now. I mean, I think 2 weeks, 3 weeks ago that we meet this guy from the green product label, and he's saying that we are going that way, but not for the moment that every product has to be certificated at the moment, yes. And about the architect that you have just mentioned, there could be some special architect, usually architects who are quite famous, that they could choose their own material. But most of the time, usually the high-rise buildings or low-rise buildings, the client actually involved in choosing the materials. And when they do that, even though we have the understanding of how to get a good green product, they might not agree with us. Yes,
right.
Right.
So when that becomes one of the challenges. And so what I find is, because I deal with clients all the time with a similar issue, and you know, I've got lots of recommendations on how to make their building more sustainable, and I'm happy to share that with them. And some people are interested, and some are not. And you know, I find if I want to keep doing business with them, I don't push them to the point where you know, they end up firing me, because that doesn't accomplish anything, right? And so what I find is over time, right, it just takes time, and so you keep working at it.
But actually, Professor Mark, that we are in the middle of this pandemic, and it does really change the way by which the clients look. Actually, they are looking. They know now that the having ventilation is much good for the health. Even though they have air conditioned. And now they are not very resisting the idea of open space. Previously, it's difficult. It's difficult for the client to agree with our, let's say, our proposal that we should have more outdoor spaces. But now it's the other way around. Yeah, pandemic, I think, it has some good use for us to.
I was planning to do, like, I was in a webinar last week in which we talked about you know, pandemic relative to sustainability, and so I've got some resources to share with you. I was planning to make that part of the lecture on Wednesday, and so some kind of ideas, and so look forward to your thoughts on what we came up with. So that'll be good. And so good. Does that help answer it? And so The other thing I've seen is you can, as an architect, you can specify without calling out a product. You can sit there and say, we want wool carpet. You know, you probably don't see this bunch of it there. Wool carpeting. We want bamboo shingles. We want you know, you can make that part of your spec. And there are certain products that are less energy intensive, you know, relative to others. And so, so that can certainly help.
At this moment, sorry, Prof. At this moment, the
no.
architects look at the R and U value
Oh,
of a specific material.
Yep.
That are the things that they can know from the specification of a material. More than that, we really don't know what, like the embedded energy and so on. Yeah.
Do your codes call out R and U values for materials and your windows also? Do you sit there and say our walls have to have an R13, our ceilings have to have an R38? Does Indonesian code specify those levels?
Yes, they are, but I'm not sure if all the materials are having that kind of code. Yeah.
Yeah.
Uh-huh.
Good.
Okay, thank you. So is there any other questions from the students or also from the other participants? Please go ahead.
Ma'am, actually, I want to ask further about the previous question.
Mhm.
Can I ask?
Please.
I mean, like for the more little scale and more, yes, in the project, like maybe, for example, like a house, like not in the scale of a high-rise building. For example, we build a house and it is not a large project, and so we don't we don't have a complicated structure and parties that join in the project. How do I mean, like in the common project like that, we usually choose like the common material, like for the cement, maybe we choose the common material. I mean, like how other than the certification in the materials, how do we know that, for example, like we have two concrete brand and they don't have any certification at all, and like how do we know that this brand is less using energy than this brand, or maybe like what I asked about it before, can we just ask the institution, the company that making it, like how do we how you use how the process you use to make this material, or like are they yes it is this okay.
I was going to say, if they don't advertise it and they haven't done an EPD for it, the chances that they were going to be able to provide the level of detail that you need, the person that you talk to, it may be challenging, right? I'll be honest. And so if you're talking to a salesperson about their sustainability principles and the company hasn't done an EPD, they don't have any, but they may be like, oh yeah, you know, they'll tell you anything to sell their product, right? And so if the products are very similar, right? And so you're looking at, you know, comparing two concretes, and they're essentially, you know, they're both coming from Indonesia. They're both using a similar product. They're both, you know, very similar. I'd defer back to the next thing and sit there and say, okay, you know, first thing is, do you want to use concrete, right? Because, you know, generally you should have a general feel of where concrete, you know, is relative to, are you going to use steel or use bamboo, right? Bamboo may be more sustainable, but if because of your condition you want to use concrete, okay, I'd look at, I got these two options. Go with who's closest to you, right? Reduce that amount of transportation, okay? you know, because you know that moving it is going to generate more pollutants also. And so if everything else is relatively close to the same, one of the things that you know, when I'm evaluating products, first thing I consider is, does it release hazardous material? Am I doing something that's going to hurt anybody because of this particular product I'm picking? Because that's one thing I don't want to do. Right. And then from that, then I start to look at the whole, right, make sure that, you know, they're doing it efficiently. But if they can't get that information, then go with what you can. And so, especially for a smaller project, they're not going to go into a lot of research for you, you know, as far as they're doing the market analysis, and you can't be offended by that. And so that's why I go with who's closer. Does that help at all? So, but what you should be able to do is you should be able to come up with, you know, the selection of concrete relative to other materials, right? That you should be able to come up with. And there are a number of resources available that provide, you know, what's the embodied energy of concrete, what's the embodied energy. Even using the simple website like Athena, it's Eco Calculator. It's a free website, and it will help you. It will select materials, and it will tell you, if you use concrete, this is a typical amount for that. If you use wood, this is typical amount for that. And so the Eco Calculator is a nice tool for just giving a quick comparison relative to order of magnitude of products. So, right. And I'll make a note to myself. I can show that on Wednesday if you guys are interested. I can kind of show how that's a kind of an, you know, it's not an exact tool, but I think it helps in, you know, if when you're not getting other data. And so, all right, would that be good? So
Yeah.
yeah, the Eco Calculator is kind of fun. It's just an Excel spreadsheet, and I'll have the website. You can download it for free, and so it's kind of a good start in the process.
Okay, so is that okay, Anil?
Yeah. Thank
Okay,
you.
maybe I would like just to add, Prof, because when the question is
certainly.
about comparing this embodied energy, we may also have a look to what concern actually this material is being used for, right?
Mhm.
Either as a facade only, or maybe in terms of material inside of the architecture, or maybe underground. We may also have a look onto the use of or the functions of the material itself in that
Definitely.
building.
Yep. Definitely.
Okay. Thank you. Now, I would like to hear more questions, please. Is there any question more?
Hello, Melva. I
Yeah.
have a question.
Please.
Yes.
Okay. I have interest in a solar panel, but what I want to know is how long the solar panel could be effective to using by us. You know, like 5 year, we must change it, or 10 year. And is the solar panel is recyclable or not? Because what I know is in Indonesia that has no popular opinion about recycle solar panel for now. And then I see that from Eco Business that I read it last night that Asia is facing the taking hazardous material if they has no law to recycle the solar panel. Is that clear, sir? Can you
Yep.
answer? Okay. And then I have interest in using solar panel too. I have a focus on micro housing, but as we know that micro housing in Indonesia usually has a narrow space between every building. Maybe the the largest or the tallest building will be shading the smaller building. Then have you a suggestion for me to place the solar panel in effective areas for, you know, have much more light that has no shading from the other? Thank you.
Oh, okay. So first off, we'll start with the duration for the solar panels, and so they're getting better. They're improving. Typical solar panels last about 20 years, but after about 10 years, they start to degrade, and so you start off with about a 75% efficiency rate, right, and then they start to go down from there, and so there's been various studies of how much they degrade by, but it's kind of tough, right? Because we don't have 20 years worth of we have 20 years worth of older panels. We don't have the newer panels to really be effective with that. the big thing that people fail to do is when you do the solar panels, you got to clean them, right? You got to clean them regularly because if they get covered with dust, soot, and these type of things, then that's going to degrade even faster. And so your environment where you operate makes a big difference also. In Florida, we have a lot of salt water, a lot of salt air. So naturally, it's going to cause them to degrade faster. Anytime you run a electricity source through a metal in a salty environment, you get lots of corrosion. So when you have these type of effects, then their performance will drop off. And so naturally, that all factors into it. So, but the salespeople will tell you they'll last for 20 years, but recognize, I figure you get 10 years of good use and you get additional 10 years of medium use out of them, right? So recycling them, there's actually been a big shift in that I've seen in the US that they're definitely wanting to recycle them. They're trying to maximize using as much of the material as possible to do that, to recycle them. And so it's a big research area. And so before I agree, it used to be a problem of disposal, but hopefully we'll see more information on that. The micro housing question, and so it's a unique challenge, right? Because you don't want to block other people's locations. And so one of the things I've seen, it's kind of unique with that, is again, when I was in New Mexico, we had Sandia National Laboratories that had a whole section specializing in photovoltaics. And one of the things they were looking at was what's called IPV, integrated photovoltaics. And so what you're doing is taking actual building materials and embedding your photovoltaics into them, right? And so your roof shingles are actually photovoltaic panels themselves. And I think Tesla is really trying to maximize in that type of thing. They came up with the photovoltaic paint. Isn't this cool, right? You paint it on and it has the photovoltaics already in it. And so you basically, by doing combination of these type of things, your whole building becomes a photovoltaic source. They were doing this really neat research on photovoltaic fabric. And the Army was paying big money to invest in this. And the whole idea of, can you imagine your soldiers out in the field, right? They're wearing their whole photovoltaic panel is the idea. And the idea is because you'd use it for your radio equipment, electronic equipment. So, so there's a lot of really neat research in that area. If you find that area fascinating, I'd recommend look further into that. So hopefully that kind of gives you a feel for directions that I've heard of some of those things.
Okay, Reski, what about it, Reski?
It's a good answer from Mr. Mark as usual.
Yep.
But I think I need more research for the micro housing so that I can say it has effective effect for the micro housing for using photovoltaic panel.
Yep, I agree.
Okay, so actually, Reski, where do you live? Sorry, I forgot.
I live in Bandung.
Okay, in Bandung. If you can have your time to come to UI, we have Soft One House. Yeah, it's a kind of research in engineering faculty. It's a kind of it's typically made for house actually, but it's made from 2 containers. But they are this kind of energy building. They use the solar power for running the energy in the house. You may have.
I see. Nice. That is interesting. Maybe I can come maybe next month to UI to see that.
Yeah. Okay.
I want to come see it too.
Yeah. Okay, Prof. Okay. Everyone is invited. Okay, so do we still have time, Prof? We already 1.5 hour to go.
I can answer more if you like.
Okay, so maybe one more questions from the audience. Is there any more questions? Okay, one more, sir, from Mas Yuri. Please go ahead.
Right. Okay, thank you, Prof. I'm agree with Mr. Sorry, not. Okay, I'm agree with Mr. Toga at the say about it's difficult to say the client to use the energy saving for a solar panel. So I want to know our experience, Prof. Russell, from America or in the world, especially for solar PV, for solar PV, how to use it in America, or especially starting from what? From a commercial building, government building, or there are certain communities, because starting new things as such as the use of solar PV is not cheap. And usually clients are a bit difficult to convince unless they have an attractive saving economy. That's maybe
the way it's you know, until recently, the biggest way it's become cost effective is because of cost incentives provided by the local government. And so I've done a lot of photovoltaic panels in Las Vegas. So the most recent one was a big hotel complex called the Wynn. I don't know if you've heard of the Wynn. And so the Wynn claims that they get almost 30% of their power from photovoltaics. And it's really neat when you go up on the roof and you see these huge photovoltaic farms that they use for the power. And they're able to do that in a cost-effective manner because the state of Nevada gives them a significant tax advantage based upon doing that. And so when you do, once they cut back their taxes by, I don't know the actual numbers, but it's you know, they've told me that their the payback period based upon the tax advantage is like 5 years, right? And so they're like, of course we're going to do this, right? And so so until recently, because of the cost of photovoltaics, the only ways I've seen that people do that is because the local government provides some type of tax incentive. In Germany, it took off really well, and back probably 10, 15 years ago, because the incentive that was provided by the utility company would sit there and say, we will buy your solar power at 15 cents a kilowatt hour, whereas if you're buying our power, you're paying 10 cents a kilowatt hour, right? So they're paying you 50% more for what you're providing them as opposed, and so that's been a big advantage to them, right? The other way that I've seen it financially work is through a thing called RECs, renewable energy credits. And so this is taking off really big in Europe. And the whole idea is that you're trying to reduce the amount of carbon emissions. And so they tax companies based upon the carbon emissions they emit. And so by using photovoltaics, you're offsetting that. And so you're offsetting a certain amount of carbon emissions. And so people will buy those RECs, renewable energy credits, to offset their carbon emissions so that they can continue to produce otherwise. And they in some situations, they find the RECs are actually far more valuable than the cost of the energy. And so it's been another big market in which I've seen that take off. And so so there's been a number of different ways. Currently, in the U.S., if you're in a location that receives more than 4 kilowatts per meter square per day of energy, based on the current cost, it is cost effective, right? Because of the cost of the panel. And so if you're more northern climates, we finally gotten a cost for PV where it's gotten down to where it's a lot more reasonable. So hopefully that trend continues and we'll see more, but it's been a while, right? It's taken, almost 15, 20 years to get to this level. And so hopefully we'll continue to improve. So does that help with that?
Yeah. Yes. Yeah, thank you. It's mean that the incentive economy from government is interesting in
Well, but fortunately, it used to be that it was not cost effective at all unless you had that government incentive. And so fortunately now we finally get in that spot where you don't have to have the government incentives and still make it cost effective. And you know, and we hope that trend continues. And it'll be interesting to see, you know, if recycling the material will help bring that down even further. So, you know, we see that with a lot of equipment. You see, for example, your laptop computer, right? If you buy a recycled laptop, it costs less than a brand new one. Wouldn't it be great if you did the same with photovoltaics? I'd buy recycled photovoltaics if I can get them at half the price. So,
Yes.
Yeah.
Okay. Yeah. Thank you very much.
Yep. Mhm.
Okay, so Prof. Mark, thank you so
Yep.
much. Also for the participant, thank you so much. I think we are we want to have it like another 2 hours, but I don't think it's appropriate because it's still time to sleep.
You'd be poking me with a stick to wake me up.
Okay, so again, Prof. Mark Russell,
Good.
today is your fourth lecture. You
Mhm.
have given us the lecture about energy environmental building.
Mhm.
So I think today we have a lot of things to bring it home. Yeah, because you mentioned about passive house, solar, photovoltaic. You also mentioning about environmental product declaration. Yeah, so on and so forth. However, maybe in terms of the business sector, this kind of energy is still quite not interactive. Yeah. And also for us as a user, it still can be seen as expensive as well.
Mhm.
Yeah, I think we both know that it's still going on, the development in Indonesia. Also, the price is getting low day by day, year by year. And yeah, let's see, because we are as the architect, we also have our responsibility to educate our users, right?
One of the things, just real quick point on that, is Europeans require, right, for all their products, they've got to have EPD. They've got to have that certification. And so Americans have recognized if we want to do business in Europe, we have to do the similar. And so we're hoping that as a ripple effect, as companies recognize if they want their products to be sold internationally, they need to meet those criteria. And so that's we're seeing over time that transition. And so I have no doubt it's going to hit you guys. You know, once you realize if you want to, you know, you've got to be in the international market, right? I mean, you obviously are with coal, and so you know, I think it's just a matter of time. And so,
Okay, again, thank you, Prof. Yes, as you may also concern that Indonesia has a lot of energy resources in terms of coal, in terms of renewable energy like solar. We have a lot. Thermal, we have also a lot. The main concern is how to optimize it on the economic and interesting for
Economic
health
scale.
sectors.
Economic scale.
Yeah,
Yep.
otherwise it's still like politics and yeah.
oh yeah,
Yeah. Okay, can we have the camera on for now because we need to say goodbye to Prof. Russell so he can continue to sleep without having bad nightmare.
it's been wonderful.
Okay, then see you, Prof. Russell. See you on
All right.
Wednesday. Yeah,
All right.
bye-bye.
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 Thank you so
Bye-bye.
much.
Thank you.
Bye.
Thank you very much.
Assalamualaikum
Bye.
warahmatullahi wabarakatuh. Selamat
Thank you,
siang.
Prof.
Thank you.
Thank you.